On Friday, August 24th, 2001, Flight TS236 took off from Toronto at 12:52 UTC bound for Lisbon, Portugal. On the plane, there were 293 passengers and 13 crew members on board. The aircraft was an Airbus A330. Leaving the gate in Toronto, the aircraft had 46.9 tonne of fuel on board, 4.5 tonne more than the required by regulations. The plane was under the hands of Captain Robert Peach, 48 years old, an experienced glider pilot who had 16,800 hours of flight experience, accompanied by the first officer Dirk de Geer, 28 years of age, who had 4,800 flight hours, with 11 cabin crew members. Weather forecast for the Atlantic crossing is good. Everything runs smoothly on the flight deck except a slight adjustment to the route. To avoid congestion, air traffic control directs the flight 60 miles south its original route. It is a minor alteration where everything was doing fine. Despite having computerized system, some checking procedures like the fuel calculation have to be done by hand. By comparing the amount of fuel in the tank with the amount the flight started with, the pilot can monitor the fuel usage. At 5:16 UTC, more than 4 hours into the flight, a cockpit warning system chimed and warned of low oil temperature and high oil pressure on engine 2. It was a very unusual reading. The pilots are puzzled. A low oil temperature indication is normally indicative of a bad sensor. Oil temperature don't usually decrease but increase in temperature. High oil pressure is a very strange indication. It's only indicative of a contamination of oil with fuel. There was no obvious connection between an oil temperature or pressure problem and a fuel leak. Captain Robert Peach and First Officer Dirk de Geer suspected there were false warning and shared their opinion with the Maintenance Control Center in Mirabel, who advised them to monitor the situation. At 5:36 UTC, the pilots received a warning of fuel imbalance. They followed a standard procedure to remedy the imbalance of transferring fuel from the left wing tank to the near empty right wing tank. Unbeknownst to the pilots, the aircraft had developed a fuel leak in a line to the number 2 right engine. The fractured fuel line, which was leaking at about 1 gallon per second, caused a higher than normal fuel flow through the fuel oil heat exchanger, which in turn led to a drop in oil temperature and a rise in oil pressure for number 2 engine. At 5:45 UTC, the pilot decided to divert to Lua JIazheng Air Base in the Azores due to the lack of fuel at the circumstances. They declared a fuel emergency with Santa Maria Oceana Air Traffic Control 3 minutes later. At 6:13 UTC, while still 135 miles away from Lua JIazheng, engine number 2 flamed out due to fuel starvation. Captain Peach then initiated a descent to 33,000 feet, which was the proper single engine altitude for the weight of the plane at that time. 10 minutes later, the crew sent a mayday to Santa Maria Oceanic Air Traffic Control. 3 minutes later, engine number 1 also flamed out. Without engine power, the plane lost its primary source of electrical power. The engine ram air turbine was deployed automatically to provide essential power for critical sensors and instruments to fly the aircraft. At 6:45 UTC, the plane sighted the airbase and circled around it with a series of turns and maneuvers to remove excess altitude for proper landing, and also to reduce the speed of the aircraft. The plane touched down hard approximately 1,030 feet past the threshold of runway 33 at a speed of approximately 200 knots, bounced once and then touched down again approximately 2,800 feet from the threshold. Maximum emergency braking was applied and retained, and the plane came to a stop at 7,600 feet from the threshold of that 10,000 feet runway. Since they had lost the anti-skid and brake modulation system, the 8 main wheel locked up, its tire braided and fully deflated within 450 feet. The plane suffered structural damage to the main landing gear and the lower fuselage.
On August 2001, Air Transat Flight 236 suffered a complete power loss 30 minutes into flight. It had a major fuel leakage, which was due to improper maintenance. There was a loss of engine power, causing the plane to lose its main source of electrical power. The plane glided for about 217 kilometers to the nearest airport in Azeros. Captain Robert and First Officer Dirk performed an emergency landing, saving all 306 people on board. 14 passengers and 2 crew suffered minor injuries, while 2 passengers suffered serious injuries during the evacuation of the aircraft. Now we have one of the passengers on board flight 236 and we'll be asking him a few questions. So, how did you feel when the plane landed safely?
When the plane landed safely, I just want to get out as quickly as possible. I didn't even use the slide. I just ran down and started crying.
So, can you explain in more detail what actually happened inside the plane?
Inside the plane, it was dead silent. You could literally hear pin drops. Everyone started to praying and screaming for God. Sorry. When we were told to put on our life jacket, people started to panic. If I were to die, just kill me now. You know what I mean? I don't want to suffer the thought of being dead sooner or later and have no control over it. Sorry.
Thank you very much.
On 19th of August 2001, there was a maintenance done before the incident. Air Transat had removed the right-hand engine for maintenance and installed a replacement unit that was sent by Rolls-Royce. As they analysed the repair log for the engine, they discovered a shocking mistake, not a case of design, but a shocking issue on the maintenance. Rolls-Royce had supplied the engine without a hydraulic pump assembly. To overcome this, the Transat maintenance crew had to use the parts from an older engine, but it does not fit properly, and the pipe has been on abrasion for 5 days. At the same time, there was an unexpected pre-service bulletin configuration which the operator has not been exposed to the engine type. The engine changing process was failed to be identified. The differences in configuration between the engine that was removed and the engine that was installed. This result to complete reliance on the technician that were doing the engine change so to detect the differences, instead of referring or consulting the relevant service bulletin which is necessary to properly complete the installation of the post-board hydraulic pump. The lead technician only rely on verbal advice during the engine change procedure. The pipe undergo high amount of abrasion within the few days before the incident. One finally broke during the incident. The pipe was also fixed with a bracket so to prevent adequate clearance and to prevent any unwanted abrasion during the flight. However, the bracket was removed during maintenance, which then caused a high amount of abrasion, causing it to break. Chief mechanic testified that he had been concerned about the substitution of the other hydraulic substitution. 5 days before the accident, he raised his concern with his superior. The company has decided that the aircraft must go back into service and could not wait for the missing part. He should go ahead with the substitution. The replacement part is only different by a few millimeters, and these differences nearly cost 306 lives. This is an issue of dirty dozen, whereby the head mechanic was under pressure by his superior, and he didn't have enough assertiveness to inform the management that the maintenance cannot be carried out until a replacement part is ready. The pilot was at fault also during the incident. The pilot did not recognize a fuel problem existed until the fuel ADV advisory was displayed, and the fuel imbalance was noted on the fuel in cam. The crew also failed to correctly evaluate the ongoing situation by taking any action. They did not recognize a fuel leak situation existed and instead carried out a fuel imbalance procedure based on memory. This resulted in the fuel from the left tank being fed to the leaking right engine. Most importantly, when the crew switched on the cross-feed valve to transfer fuel from the left wing tank to the right wing tank, they lost 17 tons of fuel in less than 30 minutes, yet they failed to close the cross-feed valve and prevent further loss. This occurred due to the pilot error when large amount of stress was placed onto him since one engine was flame out. The pilot wasn't able to think clearly, and he was only concentrating that there was a computer error in the plane, and did not analyze any further in-depth situation. Management of the company should implement schemes that allow engineers or technicians to be more assertive with their decisions so that safety always comes first before profit. Company can implement this scheme by conducting classes for the engineers and technicians so to allow them to understand how they can tackle the situation when this problem arises during the work, so that they do not blindly listen to the manager, which leads to the incident. In order to prevent the incident from happening, the management should also stock up sufficient amount of parts so to allow maintenance to be done safely and properly. Lack of parts can be endangering to the lives of the people as well as the company's profit. With spare parts stocked up, the aircraft could be maintained properly and safely so that the incident could have been avoided. More pilot training could have been done so to prevent pilots from being anxious and not understanding how to overcome the situation. Due to pilot being stressed over the engine flame out, they did not realize that the fuel was reducing drastically when the cross-feed valve was opened, causing them to not switch off the cross-feed valve to prevent further leakage. We would also like to suggest that if there's a replacement of components on the entire engine, a pressurization test on the fuel and the hydraulics line should be conducted to check if everything is working to a safe standard. Engineers should also keep track on the engine performance on the first 5 flights after it goes through a replacement to make sure that the engine is working efficiently and is up to its standard. We feel that this would help to reduce significantly the chances of leakage occurring in the future. Another suggestion that we recommend is coating the fuel line with a rubber-like material. This rubber coating will act as a sacrificial layer which will wear off first if the clearance is eliminated. Thus, it will help reduce the chance of fuel line leakage due to rubbing against each other. As the rubber will wear off first, it will also be easier for the engineer to find out the deformation of the rubber during maintenance check.
Thank you.